This conference will now be recorded.
Okay, that's good. We got 3 people so far. We got Diana and we got David. How you guys doing today? Let's see. That's good. All right, we'll give it a couple of minutes. We didn't have a great RSVP turnout for thick film, but that's okay. We'll still go through it anyway so that you guys can get a better understanding of what we do, how we do it, and that'd be great. And it looks like Ann is here. That's good. How you doing, Ann?
I'm good, thank you.
I'm trying to see here. I can do share my screen. Sorry, I'm learning more and more. There we go. All right, great. Everybody can see that screen printer or that image? Chat bubble? Yes, all right, thanks, Ann. All right, it's 3:01. I'm usually a pretty punctual dude, so I like to start things on time, but you know what? I'm going to give it another minute. We'll see if we get anybody else. I hope everybody had a nice Thanksgiving and everybody's safe and healthy and doing what you need to do to make sure that you and your family stay safe. You know, scary stuff going on. All right, we got Stephanie too joined us. Hi, Stephanie.
Hello, how are you?
I'm doing well, thank you. All right, we're about, here we go, 3:02. All right. So, for some of you, this might be your first Stellar webinar Wednesday or tutorial. This is our 5th or 4th, I believe. We've done a Stellar intro. We've done thin film. We've done direct bond copper. All these videos are available on our website in the news section, as well on our YouTube channel, Stellar Industries Corp, if you search. And if you take a look, you know, please give a watch. And if you like them, just throw a like and subscribe. My kids would be happy because that's what their favorite YouTubers say. Throw a like and subscribe. So this week's tutorial is going to be about thick film. Thick film is another method of substrate metallization that we offer here at Stellar. It is one of the metallization techniques that was first here at Stellar, I think followed by thin film, then DBC, but we're going on probably 30 years. We have been screen printing here on ceramic. Initially to figure out a way to metallize aluminum nitride, which kind of came on the scene in the 80s to replace BEO. So, but Thick film is used to produce electronic devices by screen printing a conductor onto a ceramic substrate. It's interesting, the screen printing process doesn't require photolithography. And this can be combined with alternating layers of dielectric materials to create a multi-layer structure. Now, Stellar typically sticks to single layer conductors. And let's see, get that to pop up. There we go. This is a good example of a single layer gold conductor on aluminum nitride. And it is a low-cost method to produce substrates and submounts in reasonably higher volume. Also, you know, if you're looking for functionality versus, let's say, you know, you can sacrifice functionality. I need this to function and do what I need it to do. I need it to be good enough for me. It's an excellent replacement for thin film, because thin film can be quite expensive even for a small run of parts. So if you're saying, hey, Jason, I need to wire bond with 1 mil gold wire, I need to solder using tin lead, I need to solder using gold tin, that's all going to change the type of construction that we offer you. So we always encourage our customers to give us the most information possible about what it is they're doing with the part, so we can suit them with A, the right material, and B, the right metallization technique. We can make as few as 10 to 25 pieces in a thick film run, obviously depending on size, and in some cases up to several million pieces. It all depends on the complexity and size of the parts. Now, let's first talk about one of the keys to thick film metallization, and the method of application, which is through screen printing. We purchased thick film printing screens from a company called RIV, R-I-V. The company is amazing to work with, and their owner, Tanya, really keeps them at the top of their game. So if anybody from RIV ever listens to this, thanks for your support, guys. We couldn't do this stuff without you. Screens are essentially metal frames with a screen in the center. Similar to, let's say, like a window screen, but on a smaller scale. And you can get the screen mesh with lower mesh count for thicker features and thicker metal deposition, or deposition, or with a higher mesh count, which allows for smaller features and a thinner metal thickness. The mesh is typically going to be stainless. Okay, and let's change pictures here. We'll go to one of these screen printers, okay. Then what ends up happening is you coat the screen with an emulsion, which is got very good adhesion. And then the screens go through a photolithography process where you're left with a pattern that allows your thick film metal, which is a paste or an ink, to pass through the screen into your desired pattern. So as you saw here in this image, these are all openings in the screen that the metal is then deposited into that actual pattern, which is nice. So there's a photolithography spot, but in this case, there's not etching and there's no ion beam milling required. And the photolithography process is done in the screen making process, which is great because it's going to be more cost effective for you to buy a finished thick film circuit from me than it would be to buy a finished thin film circuit from me. It's a super cool technology, and if you need screen manufacturing, I definitely recommend that you call RIV. I was not paid for this promotional material. I just think they're an awesome company, and they've always done a good job for us. So these screens are then mounted. Let's see, let me move my screen. Right here, you can see the screen. Okay, and you can see the area that's going to get screen printed. In this case, I think it's a 3-inch square. Okay. We then flood the screen, which is a method of loading it with the conductive ink or paste. These conductive inks or pastes are typically bought from two companies, either Heraeus or DuPont. There's a couple other guys out there, but Heraeus and DuPont are the big boys. They oftentimes have materials that are compatible with one another. So both are very reputable, high quality houses. These conductive inks and pastes can be RoHS compliant, which if you don't know what that means, it means free of lead, cadmium, and nickel. So after we've loaded the screen and the part is loaded on here, this platform lowers down. You have your ceramic mounted here. And a squeegee will then drag across the top of the screen, pushing the paste through the screen onto the ceramic substrate in the pattern you desire. So let's see. So in this case, right, it would be screen printing this pattern we have here on one side, because you're only able to do it in on one side at a time. Okay, then after we screen print the ink in the pattern, you would then dry the parts where the ink or paste is dried, and then there's a firing operation which really bonds it to the ceramic, and that's done about 850 degrees C in air for a set period of time. If additional sides are printed, you could do it multiple ways. So if you see here, we have two sides printed, which is something that Stellar is very good at. Not a lot of companies in the world can do. So you can do this two methods. You can print dry per side and then fire the finished parts. So in this case, the way I described it is you print dry this whole side, then you print and dry this whole side, and then you fire it at 850 C. Or you can do print, dry, fire, print, dry, fire. So in this case, on these parts, we do print, dry, fire side A, print, dry, fire side B. And you do that until you have a finished part. We also are offering etchable thick films, which allow us to get finer features, and I'll tell you why. Because in a guy like this, right? This one was screen printed with a conventional screen print method. And the finest feature we can achieve there is about 125 microns or 5 mils. You know, to the layperson, 5 mils is tiny, but in the electronics world, 5 mils can be a mile. So if you need something like, you know, 12.5 to 25 micron feature sizes, then, you know, talk to me about thin film, because that's how we're going to get it. The print tolerance on something like this screen printing is about plus or minus 75 microns or 3 mils. Now, with the etchable thick films, we can get you finer features such as 75 micron feature sizes, which is about 3 mils. So you can see going from 5 to 3, we can get a lot more condensed and achieve much more complex circuitry. So it's up to you on how you want us to do it. We can do both. We offer thick film on aluminum nitride, aluminum oxide, beryllium oxide in various grades and thermal conductivities. We also offer solder mask or dielectric layers as an additional layer. That would probably be the extent of our multi-layer thick film, is doing a conductor and then a dielectric. But come to us with your custom requests or requirements, and we'd be happy to look at your design and offer some advice as to how we could best do it for you. And like all of our other products, everything is custom. I don't make any real off-the-shelf type stuff. You know, some designs may be similar between our customers, but rarely is anything ever the same. Does anybody have any questions? All right. Okay, that's a good question, Anne. Asking regarding the over edge connections, and let me grab that picture. There we go. Good. How do we make sure that side A and side B are connected properly? Well, we will absolutely guarantee that those two sides are connected. I can't tell you how it is that we screen print, what our method is for achieving that connection, because it is proprietary, but I can tell you I would guarantee that we would connect both side A and side B. Any other questions? There, I have a, let's see.
Hey, Jason.
Yes.
Okay, can you hear me? This is Pat.
Hey, Pat, how you doing?
Good, how's it going? Hey, I had a question on the thickness of the substrates. What are your substrate thicknesses for these
Pat
thick
Reichert?
film parts? Yes, it is. How you doing, man?
I'm better now that I'm on the phone with you.
Okay.
All right, fire away, man. You're talking about ceramic thicknesses.
Yeah, I'm wondering what are the ranges of substrate thicknesses for the thin film? For the thick film applications.
Standard thicknesses probably would be 250 microns or 10 mils and above. Now, can I do thinner? Probably, but when I do thinner, I'll probably end up reducing the overall substrate size that I start with. So in most cases, I want to start with what maximizes in my screen printer, which would be about a 3-inch square. But if I get down to, let's say, 8 mil material, I probably want to start going down to a 2-inch square just for fragility purposes.
Okay. Okay, and sorry, my second question is on the parts that you show on the screen right now that have a 90-degree turn.
Yes.
Is the thickness uniformity across that edge pretty good? In other words, if you were to use those for, say, a high current link, I wouldn't want a thinner section right there on the corner.
You want a thinner section on the corner?
No, I would not. I would want it to be uniform so that it doesn't act like a fuse, basically, right at the edge.
Well, due to the nature of the wrapping, it does end up being slightly thicker right on that corner. You get a bump on either one side or the other.
Okay, thicker is probably fine. Thinner would not be good. Okay, got it.
You definitely don't get thinner. Typical thick film thicknesses for us are going to be somewhere in the 6 to 12 micron range.
Okay, thank you.
You're welcome. There was another question that came through. For which currents is it usable? I don't have the answer to that question, Anne, but if you would send me an email to, here, I'll send you. An email to my email I just put there in the chat screen. I will find out and I can get you an answer within a day or so. I know that's relatively low compared to some of the other products that I use, or some of the other metallization techniques like thin film, which has a higher degree of purity to the metals, and direct bond copper, which obviously copper is a killer conductor. So. You're very welcome. Any other questions? All right, I'll give you guys another minute to think if you can come up with something, but let's see. This is another angle of those parts. Yeah, Pat, just to reiterate, it is never going to be thinner here. You would think it would, but it's not based on the method that we do. And I'd love to make some of these for you.
Okay, I see that. Yeah, thanks, Jason.
You're welcome.
That's a good angle there.
All right, so no other questions. What I can tell you is our next webinar is going to probably be the best one yet. It's going to be about our microchannel coolers, which is a multi-layer cooling structure using copper that's bonded together at very high temperatures. Now, what the best part about this is going to be that Stellar is or has developed a standard cooler so that we won't necessarily require custom designs from now on. We'll have an off-the-shelf design that you could buy in any volume. Right now, we're making coolers in the range of thousands of pieces per week, which for a complex part, that's quite the feat for a smaller company like ourselves. So I will send out a constant contact reminder. I'll probably spam a little bit. I found that if I'm a little more passive in letting people know what's coming up, we get a lot less of an audience. So bear with me and my email blasts, please. It's just going to be announcing our microchannel cooler tutorial that's coming up before the Christmas break.
Hey, can I ask one quick question?
Yes.
That part that you had showed with the 90-degree angle with the gold
Yeah.
on either side,
Yes.
what would be the end application for a part like that?
In this case, let's go back to it. Share screen. Okay, in this case, like a tombstone, where it mounts on the edge, and for a photo detector.
Okay.
But that's why it has the sharp corner there, because it's edge mounted.
Mm-hmm.
And
Okay.
you'll see,
Gotcha.
and if you can see right here, you can see a little bit of a relief. So when we're cutting down this side, we cut down a little bit into this surface, just to make sure that you don't have a radius that would get in the way of you mounting it properly over an edge.
Okay, gotcha. And then would you wire bond to that?
Sure can. You can wire bond to it. You can solder to it. But what you're using is really going to determine what I use to metallize the part with. So if you said to me, I'm using 2 mil gold wire, but I want to use SAC solder, right? We may give you one metallization type on a few traces, and then we may give you another metallization type in another few traces or spaces, depending on where you're going to solder and where you're going to wire bond.
Okay. Okay, gotcha. Thank you.
You're welcome. If you have any questions or you have a detailed design or even a sketch, you can always just email me and we can start up a dialogue.
Great, thank you.
You're welcome. Any other questions? Okay, that's a wrap then. My email is in the chat section. You can always find our contact information on our website. There is a section on thick film Within that section of the website, there are our thick film design guidelines. But I encourage you to call me, email me. I love to talk about this stuff. I'd love to help you out. And I'm looking forward to our next webinar Wednesday. So, oh wait, one more. Oh, thanks, Pat. It's good to talk to you. You guys have a great day.
Take care, Jason. Thank you.
Thank you. All right. Bear with me one sec. You're very welcome. Trying to close this. There we go.